Welcome to part 6 of the video on question and answer series. In this video I'm covering many of the short notes or definitions of different terms that can come up in the exams and which have already come up also in the past papers. What is a definiendum? The term definiendum refers to the word, phrase or concept that is being defined in a definition. So, definiendum refers to the word, phrase, or concept that is being defined in a definition. It is the subject or term whose meaning needs clarification or explanation. The definiendum is always paired with the definiens, which provides the meaning or explanation of the definiendum. Let's understand it with its key characteristics and examples also. The focus of definition. The definiendum is the thing to be defined. So, for example, if we have to define dog, then dog is definiendum. Dependent on definiens. It gets its meaning from the explanation provided by the definiens. So, what is a dog? Dog is an animal. So, when we say it is an animal, so that is definiens. In logical structure, the definiendum appears on the left side of the definition. So, we say dog is an animal, whatever, and more description of it. While the definition appears on the right hand side. The definiendum appears on the left, definiens appear on the right side. Let's look at the structure of a definition. The general format is definiendum equals to definiens, means this will be explaining what this term is. For example, triangle is a definiendum and its explanation is a three-sided polygon. Definiens. This is a very simple thing. Let's look at more examples. Circle, definiendum, a plane figure where all points are equidistant from a fixed center. Definiens. Contract is a definiendum. Its definiens, meaning its explanation, is an agreement enforceable by law. Let's not go into the philosophical example, that's okay. Now, what is the relation to definition process? The definiendum and the definiens work together to convey meaning. Clear. A clear and precise definition ensures that the definiendum, that is the term to be defined, is understood without ambiguity. This relationship is critical in legal, academic, logical reasoning to establish shared understanding. Let me take up the next topic in this video only. Hold on. Okay, the next short note or even a detailed explanation is on what is primary induction and what is secondary induction. There were two reasonings earlier that I had mentioned, deductive reasoning and inductive reasoning. So here it is like a primary induction. So let us understand what it is. Primary induction is a form of inductive reasoning. So it is a part of inductive reasoning divided into, this is inductive reasoning divided into primary and secondary reasoning, where general principles or universal truths are derived from the direct observation of a specific instance or facts. So this was already explained in the definition of what is inductive reasoning. It moves from specific instances or facts or observations to a general conclusion. It involves starting with particular empirical data and drawing general conclusions without relying on prior knowledge or established theories. Key features. Empirical basis. It is based purely on observed facts or cases. No prior assumptions. Conclusions are drawn without the influence of existing theories or hypotheses. The aim is to move from a particular observation to broader generalizations. The validity of the generalization increases with repeated observations of consistent pattern, meaning the more the quantity of observation, the more valid that conclusion will be. So the key features are empirical basis, that is based purely on observation. Conclusions are drawn without influence of existing theories. it moves from particular observation to broader generalization and reliance on quantity of observation or data. Example, observations in everyday context. All the swans I've seen so far are white. Generalization, all swans are white. This conclusion may be revised if a non-white swan is observed later. Scientific context. A magnet attracts iron filings every time I test it. Therefore, I generalize that magnets attract iron. Legal context. In every past case involving negligence, the presence of duty of care was critical for establishing liability. Now we can generalize from this that the presence of duty of care is a general requirement in cases of negligence. So this is still valid. Foundation of knowledge. What is the significance of primary induction? Primary induction forms the basis of many scientific discoveries and legal principles as well. Conclusions drawn through primary inductions are tentative, probable, and open to revision upon encountering new evidence. What are its limitations? The conclusion may be invalid if the observed cases are not representative. Very important. If the data set does not completely represent the class, then the conclusion will be invalid. Subsequent validation and testing are necessary to establish the reliability of the generalization. Primary induction is a fundamental process in reasoning that allows for the formulation of general principles from specific observations. So from specific observations we move to general conclusion or general principles. While powerful, it must be used cautiously to avoid premature or flawed generalizations. Next topic. So we are not doing the secondary induction, we are just doing primary induction for time being. Next topic is about the concept of singular and general terms. This already we have done, so we'll go through this quickly. What is a singular term? All these questions have come in the past paper, so I'm taking it up here. A singular term refers to a specific individual, object or entity because it's singular. It is used to denote one particular thing or person and is usually associated with a proper noun or a specific description. For example, the Eiffel Tower refers to a unique structure in Paris. Mahatma Gandhi, a specific individual. This book, a specific object being referred to. Whereas a general term refers to a class, category of objects rather than a specific individual. It denotes a property, characteristic or relation that applies to multiple entities. For example, birds applies to all birds such as sparrows, crows, etc. Lawyer refers to all individuals who practice law. Building is a general category that includes all buildings, commercial buildings, skyscrapers, bungalows and all of that. Let us look at the key differences. Singular term refers to one specific entity, general term refers to a category or a group. Singular term example would be Mahatma Gandhi, this book. General term would be tree, lawyers, etc. Singular term is specific and unique. General term is general and applicable to many. Singular term represents often a proper noun or a unique item, whereas a general term often refers to or represents a common noun or a category name. So how is it important in logic? Singular term is essential for precise reference in arguments or statements. That is very true. Useful in universal or existential propositions, which we studied in the earlier video, to describe patterns or relations among categories. So we use general term in classes, in categories, and it is connected with universal or existential propositions. Examples in law. Singular term, the Indian Constitution, a unique legal document. General term, Constitution, refers to all legal frameworks in various countries. Let's move on to the next question. Okay, explain or write a short note on truth, validity and soundness. So what is truth? Truth is a property of statements or propositions that align with facts or reality. A proposition is true if it corresponds to the actual state of affairs. So remember this, propositions are either true or false. Conclusions or arguments rather are valid or invalid. But propositions, which also includes premises and conclusion, are either true or false, and arguments are valid and invalid. Example, the earth orbits the sun is true because it aligns with scientific facts. The truth is about the content of a statement and its agreement with reality. Validity. Validity is a property of logical argument. As I said earlier, whether it's valid or invalid is a property of a logical argument, whereas true or false is a property of a proposition, not individual statements. An argument is valid if its conclusions logically follows from its premises. Conclusion logically follows from its premises, regardless of whether the premises are true or false. Example, all cats are animals. All animals are mortal. Therefore, all cats are mortal. This argument is valid because the conclusion logically follows from the premises. Validity concerns the structure or the form of the argument, not the truth of its content. This is also a very important keyword to understand, that for an argument to be valid, its structure has to be valid. Logic is not concerned with the truth of the content of the premises. So the premises can be false, yet the argument can be true. Not the conclusion, but the argument can be true. Argument can be valid. Soundness. Soundness is a property of arguments that are both valid and have all true premises. So when we say soundness we can define it as when the argument is valid and all the premises are true. A sound argument guarantees a true conclusion. For example, premise 1, all humans are mortal. Socrates is a human, therefore Socrates is mortal. This argument is sound because it is valid and the premises are true. Soundness is a higher standard than validity, as it ensures both logical consistency and factual accuracy. Let us do a comparison table. Truth, validity and soundness. Truth applies to individual propositions. Validity applies to arguments. Soundness applies to both arguments and the propositions. The focus of truth is on correspondence with reality. That is, it should match with reality. The focus of validity is with the logical structure, and the focus of soundness is both with logical structure and true premises. Truth, there is no guarantee whether something is true or false. Validity also does not guarantee truth. Soundness, yes. In soundness, both the truth and the validity have to be true. Then only, that is, the proposition has to be true, premises have to be true, and the argument has to be valid for the soundness to be true. Just to summarize quickly, truth concerns the factual correctness of individual statements. Validity ensures the conclusion of an argument logically follows from its premises, and soundness combines both, requiring valid arguments with true premises, ensuring that the conclusion is also true. Let's move on to the next video. Next question and answer. Okay, in this part we are looking at the propositional logic symbols. In simple propositions, the propositions are represented by the capital letters P, Q, R, etc. Let's look at the different type of connectives. We already saw in the previous video, negation is represented by this symbol or by this symbol or even by minus symbol. Some different places it's represented by different symbols. Here we are going to use the L symbol, like sleeping L symbol. Example, this represents not P. That is, it is not P. Conjunction represented by the symbol, and it means and. Example, P and Q, which means P and Q, like this. This is and symbol. Disjunction represented by the V symbol. It means or, P or Q. Conditional statement. Right-headed arrow key. If then. Example, if P then Q. Biconditional, both ways. If and only if. If and only if P then Q. If and only if it is P, if and only if Q. Let us look at categorical logical symbols. A is universal affirmative, that is all SRP is symbolized as for all X, if X is S, then X is P. E, universal negative, no SRP is symbolized as for all X, if X is S, then it implies that X is not P. This is what it means. No SRP. I, particular affirmative. Some SRP is symbolized as there exists an X such that XS and XP, that is, they are both connected. O, particular negative. Some S are not P. Some are not. Some are. Is symbolized as. Let's look at the examples of symbolization. Proposition, if it rains, the ground will be wet. That is, it implies if P, then Q. Where P is, it rains. And Q is the ground is wet. If P, then Q. Proposition, all humans are mortal. For all X, if X is human, then X is mortal. Proposition, no animals are plants. No animals is universal quantifier. So we say for all X, if X is an animal, then X is a plant. And then we negate it by putting a negation symbol where we say X is not a plant. So because we are saying no animals are plants. I hope this is also clear. Let's move on to the next question. Alright. Next is test questions on symbolization and logical analysis. These questions are coming in the question paper, test paper, for 6 marks, I suppose, where we have to symbolize, even 2 marks also. So let's look at symbolize the following propositions. If the sky is clear, then stars are visible. So how do we do that? They have shown us the technique of symbolizing it. So let us try our own way. If the sky is clear, so let us say sky is clear is clear. We will write C for clear. If CX, then it implies then stars are visible. So we say visible is the more appropriate one. If sky is, or we can write SX. SX would be better. Sky is clear, then it is visible. Now, because this will be valid for all, and this is an implication comes in the universal quantifier. So we can even write it like this, because it's a universal quantifier. No philosophers are scientists. So when we do obverse, we write this as no goes into E goes into, this is a E statement. This goes into A statement in an obverse. There's a converse and then there's an obverse. If you haven't seen my earlier video, please go and check that, because I've made it very simple and very clear in those videos how to do the conversion from A to E, A to I. A to I is in converse, A to E or E to A is in obverse. Don't get confused with all these A, E, I, O. It is very, very simple, believe me. Once you understand the concept, what it is, take your time, go through this. If you still don't understand, let me know in the comment section. I'll try and answer that, make it more simple, but be sincere in trying to understand the concepts. I'm sure we all have cleared our CETs, so we are all sincere in doing our law studies. I hope nobody's offended. No philosophers are scientists. So basically, this is a E proposition. We'll convert it to A proposition to make it more simple. So we say no becomes all. In obverse, we keep the subject and the proposition in its place, but replace the subject and the predicate in its place, but we replace the predicate with its complement. So we say non-P. So then it becomes very simple to write the symbol format in the symbolic format. So we say for all x, if for philosopher we'll write px, and for scientist we'll write sx. And now we know this is not a scientist. Non-P means not a scientist. So for all x, if x is a philosopher, then it implies that he is not a scientist. So he's not a scientist. My bad. He's not a scientist. This way, because we are saying non-P. So this becomes much more easier to put the negation symbol. Some birds can fly. This is a simple E proposition. This is a simple I proposition. Excuse me. It's an I proposition. It says some birds can fly. We know some stands for existential quantifier. So we use the mirrored E symbol. We say, and this is an and. If it is a bird, then and it can fly. That is how we understand this. So bird would be bx and can fly. So these are together. So fly. All lawyers are analytical thinker. This is the A proposition. So this is an implication. So lawyers would be Lx, implies are. So it's a positive. So they are analytical thinker. We can write even this way also, ATX. Doesn't matter unless we specify at the down below where it says where ATX is analytical thinker and LX is lawyers. Some athletes are not vegetarian. So some means again existential quantifier. EX. I'm just saying EX, it's not EX. So for there exists some X. We'll look at the proper wording for EX later on in the examples. Some athletes are not, athletes would be A, not vegetarian. Now this is a negative, not vegetarian. So we say vegetarian first. So vegetarian, and then apply the negation symbol for not vegetarian. And since it's an existential quantifier, we have to use the and symbol. And athlete. Athlete would be for AX. I hope this is also clear. Alright, let's analyze the following proposition. For each proposition, identify first the type, whether it's an A, E, I, O. Identify the distributed or the undistributed terms. Distributed means it applies to all the members of a class. Undistributed means it does not apply to all the members of the class. Symbolize the proposition in its logical form. Now again there are more example. All students are diligent. Very simple. All this you can take it for homework. You can freeze, you can stop the video here and solve this on your own. Once again, if you don't understand this, let me know in the comment section. I'll help you out, if time permits, that is. There are more question answers. Now these are in a different kind of format. If the sky is clear, again, if P then Q, then the stars are visible. P is the sky is clear. We have to write this, okay? P, the sky is clear, and Q stands for stars are visible. Like this we have to write so that it becomes clear. Symbolization is this. The more definition of what P stands for, what Q stands for is this. No philosophers are scientists. No philosophers are negative. I think we solved this earlier, did we? No philosophers are scientists. That was this one. Let's see if it's correct. No philosophers are scientists. That's correct. Next is some birds can fly. So all of this we have already done. This is the answer for what we had solved earlier. So you can just go through the question answers quickly and freeze the video where required. Alright, now we are also looking which term we are going to also learn and understand what is distributed terms and undistributed terms. So distributed refers to the class of objects or members, all members in a class. So that is a distributed term. It applies to everybody in that class. It's getting distributed to everyone. So type A, distributed is the subject, that is students. In this case, students is distributed. Diligent is predicate, and it is undistributed term, because generally this is for singular and this is for a class, because you cannot reverse it. Some politicians are honest. So this is type I. We know that some are is always type I. Some are not is type what? It is type O. Distributed terms, none are distributed, because you can understand it by this example. So this is S group, S class, this is P group. Now this S class, many of this is distributed, or it is rather the P class also applies in the S, and S class, the members of the S are also distributed in the P. So this both are not distributed, they are undistributed terms, because they are spread out. I hope this is clear. So some parts of the S is going into P class, some P is going into S class. They are not separate. Whereas in the A proposition, I can explain through Venn diagram. It says like this, say all S is P. Now S is all S is P, right? And we said all P are not S, but all S are P. So S is distributed and P is undistributed. Similarly for I, no S is P. So both are distributed in a E proposition. We can learn from this time. Both the subjects and the predicates are distributed terms. Undistributed terms are none. Some humans are not. So it is similar to this. Some humans are not. So this portion is not. Some P are not S, or some S are not P. So both terms are some humans are not selfish. So distributed term is predicate. Some humans are not selfish. They don't fall in that category. So this has to be checked. I'll come back with this later on. It says it's a reverse. Predicate is the distributed and undistributed term is the subject. We'll cover this later. Now there are these practice questions for you. If you would like to do this, feel free to complete this. So this completes my part topic on symbolizing of propositions and logical analysis. Let's move on to the next question. So in this video, we are looking at the substituted words or synonyms for the four types of propositions A, E, I, O, and how we can analyze or how we can understand what different terms can apply to which proposition. For example, when we say every is not there in the four types A, E, I, O. Each is not there, any is not there, invariably is not there, without is not there. So what are each of these terms mean? So in A, every means all, each means everything, means again all, any means again all, invariably means all, without exception means includes everything, means all. So these words we'll have to remember and understand that they are all pointing to the all proposition. So whenever we see any kind of this statements, we have to automatically assume that this is a proposition. That is, it says all SRP in whatever word it may be, but it ultimately comes to this proposition, a proposition, universal affirmative. Similarly, for E proposition, we start with no. No means none, not a single, no vehicle, never are lawyers, never means no, under no circumstances, again no. I means some means a few, occasionally, at least, certain, there exists some, and so on. O proposition, some are not, same type it is, a few, occasionally, there exists some not, certain people are not, at least one judge is not, and so on. Alright, in summary, let's see all of them together. A is all. Substituted words are every, each, any, without exception, invariably. No would include none, not a single, never, under no circumstances. I proposition would be some, a few, occasionally, at least one, certain, there exists. In O proposition, some are not, a few are not, occasionally not, certain are not, at least one is not, there exists S that are not P, and so on. I hope this video also helped you. Kindly wait for the next question series. These are the answers for the previous questions. I will go slowly through this, scroll through this. You can solve these in a symbolic format also, but in this case we are just looking at what is the distributed term in each of these. I'm not going to explain this answers or these solutions, but these are only for you. You can go through them, pause it as and when required. To understand what is distributed and undistributed terms. Okay, next is the symbol. The symbol is a intersection symbol. So it is a common notation in logic and set theory, but there are many other symbols used in various logical contexts. And now let's look at the comprehensive list of common symbols used in symbolic logic along with their meanings and examples. So these kind of questions come up in the exams, semester exams. So let's go through that. This symbol means intersection. It means basically it's very simple if you understand through the example. So let us say we have two sets, A set and B set. Now what is common in both set is the intersection symbol. So it says A intersection B is equal to the set contains 2 and 3, means 2 and 3 is common in both of them. The elements common to both sets. That is all it means, intersection. And union means what is common in both is repeated only once, is stated only once. So represents the union of the two sets. So we don't write here in the union A union B as set of 1, 2, 2, 3, 3, 4, not like that. But instead we make it singular. If numbers, even if there are 5 A, B, C, D, E, if 2 is in them also, all of them, we still state only one time. So 1, 2, 3, 4, like that. So this is union. Symbol of union stands for U. Intersection is N. This is a set difference. What does it mean? If you see here, represents the difference between the two sets. The set of elements in the first set but not in the second set. So this only states what is there in the first set but not in the second set. So we are not concerned with the second set at all. We are only concerned with what is there in the first set but not present in the second. So we say 1 is there in the A set but is not present in the B set, because in the A set 2 and 3 is there and the B set also 2 and 3 is there. So we state only what is not present in the B set, or alternatively we can say we state only what is present in the A set compared to the B set. This is the subset symbol. It indicates that one set is a subset of another. That is, all elements of the first set are in the second set. Example, A is a subset of B, which means B has both 1 and 2 in them. Therefore, A automatically also becomes a subset. This can be also written like this. B is equal to A, comma 3. Like this, A comma 3, which means A stands for 1 and 2. So we can write B is equal to like this. So A is a subset of B. So let us revise all the symbols. We have this symbol, we have the union symbol, we have the slash symbol, and what have I missed? Subset symbol. The subset symbol. Now, the difference, this is a set difference, and the first one was intersection, the union, set differences, and subset. Propositional logic symbols. This we have already covered. Negation. Implication also we have covered. Biconditional we have covered. Conjunction we have covered. Disjunction we have covered. Double implication. Double implication is if and only if, is it? Let's check. Used to represent a more formal or stronger implication, often in mathematical proofs or set theory. So we are not studying this right now. Let's move on to the quantifiers. This also we have studied. Universal quantifier represents for all, for every. There is at least one in the existential quantifier. So the wording that we were looking for in earlier when I mentioned EX, it was there exists an X such that till here we have to write. Alright, we are not going into all of these in this particular video, but if somebody wants to go through them, I'll scroll down slowly. This symbol means mathematical symbol means element of, denotes membership in a set. For example, 2 is a member of a set, is an element of 1, 2, 3, means 2 is an element of the set 1, 2, 3. And E slash is not an element, denotes non-membership in a set. 4 is not a member of this set. For all X in set A, this means for all X, there are all sets, all X in set A. We are not covering summation, product, we are not going through that. Alright, so this also topic is concluded. Alright, so this completes the video here. I have covered many of these topics, separate topics into one video so that we can move faster. Thank you very much if you are stuck till the end. This is one of the important videos, I suppose, because many things are covered in this for summary and for exam point of view. So thank you very much for being there till the end. Do share it with your friends if you have benefited anyhow from this video, even a little bit. I would suggest that or request you to share the link of this video with your friends so they too can benefit, because many of our professors and many of the students also find this elementary logic subject quite difficult to grasp. I don't claim to be a teacher of elementary logic. I'm still a student, and I too may be making some mistakes either in verbally when I'm stating something. I may be saying something but writing something else, which has happened. I have gone through other videos of mine, and there are certain places where I'm saying something but I'm stating something else. That is, I'm writing something else and I'm reading something else. So these mistakes can happen, but my concepts I feel are quite clear as far as logic is concerned. Thank you very much. Take care. Bye bye.